Alright, good morning. This is Mr. Ronald, and I'm going to show you the video of how I answered all the questions of this Cambridge International Examinations, Cambridge Primary Checkpoint, year 2015, month of October, paper number 2. Alright, so the materials that we need our pens, pencils, and of course eraser, ruler, protractor, calculator, and tracing paper. Tracing paper is an optional material though. Alright, so what are the things that we need to pay closer to this paper while answering it? So it says here you have to write your center number. You can see, write your center number, candidate number, and the name and the spaces at the top of the page. Write in dark blue or black pen, which means that you cannot use red or purple or whatever other than black and blue. Now, do not write in any of the barcodes. So as you can see here, so what I needed to do is to not write anything or not doodle anything on your paper. So answer all questions. It says here the number of marks in the given brackets at the end of each questions are part questions. You should show all your working in the booklet. So this is what we need to focus with. Show all your working in the booklet. All right. So here I'm going to show you the first question. Now it says here list. Here is a list of numbers and draw a ring around two numbers with a total of 74. So what you need to do is to look for these two numbers that will add up to 74. So the answers are 28 and 46. So if we add up 28 and 46, that will give us an answer of 74. All right. Question number 2. It says, here's the list of the same numbers. Draw a ring around two numbers with a difference of 9. So you have to look for two numbers that when you subtract to each other, the answer will be 9. All right, so based on what I can see, the numbers are 52 and 43. So if I subtract 52 by 43, the answer becomes 9. All right. Okay. Now let's go to problem number 2. It says here, write the missing numbers in each box to complete each sequence. So the first thing that I need to pay attention here with is the sequence between two numbers like sitting or having to the left and to the right or beside each other. So what I can see here is that the 25 and 28 are the numbers beside each other that are given, which means that I have to look for the sequence of these. So as you can see, from the 25 it jumped up to 28, which means that it went up 3 counts to reach 28. So that means if we are going to get the previous number before 25, so that means it skipped 3 numbers for it to reach 25, which means that you have to subtract the 25 by 3 for you to get the answer 22. Now the same thing follows to the next blank. So let's say for example this is 13 and we know that it adds up by 3, and this is going to be 16. And then for us to check if the number is correct, then we should see that the difference between these two numbers is 3. Okay, the next one will be letter B. As you can see, these are the numbers that are given that are beside each other. So from 9, it went down to 7, which means it went down 2 counts. Now, from there, what we need to do is to think that these 7 will go down 2 counts as well. So this will give us 7 minus 2, which gives us 5. 5 minus 2, which gives us 3. 3 minus 2 gives us 1. Now, for us to reach the next number, what we need to do is to imagine that we have a number line. The number line, 1 count backward before 1 will give us 0. And then the number that next to 0 would be a negative number, which is negative 1. So that gives us the answer negative 1 for that number. Or if you're going to think about it, this is just like solving integers, which means 1 minus 2 gives us negative 1. All right. Now let's go to the next numbers. Now, calculate the size of angle A. So angle A is the outer angle of these two given to the exterior angles. Exterior angle of this particular angle. Now, as we know, it makes a full rotation of 360, which means that for us to get the answer of the exterior angle, all right, so what we need to do is to subtract 360 by 70 to give us an answer of 290 degrees. All right. I hope you can catch up with that. All right, we're now going to problem number 4. So problem number 4 is adding fractions. So what we know is that for us to add fractions, we have to have similar denominators, or what we call the similar fractions. So the first thing that we need to do here is to put 10 on your denominator. Now, as we know, in a fraction, for us to get a value of 1, we have to understand that the answers or the numerator must have the same value with the denominator. So let's say, for example, I got 3 over 3. If I have 3 over 3, that gives me an answer of 1. If I have 4 over 4, that would also give me an answer of 1. Which will give me an idea that I have to look for another number that I could add up to 4 so that the answer would be equal to 10. Which means that I need to put a 6 in here for me to get 10. Got it? Alright, let's move on to the next problem. Problem number 4. Problem number 4 says here are 4-digit cards. So you have 4-digit cards here. Anna chooses 3 of these cards to write 3-digit numbers. So she chose 3 cards to write these 3-digit numbers. Now it says here, write all the 3-digit numbers that Anna could make between 350 and 450. Now the technique here is for you to start at the smallest number, or the smallest possible number. So if this is 350 and you have 35, so what you need to do here is first to focus on the number with the digit 35 and automatically put in the possible answers that you can get. So 35, and the next option will be 352. the next number after 352 is, of course, you have the 3, 5. The only option that you can have is 2 and 4. So we can have it as 3, 5, and 4. All right. Now, once you're done with the number 3, 5, there will be no other options for this one because the other numbers are, of course, lower than 5. All right, to continue with this, we ended up with 354. So there will be no other possible numbers from 350 to 399 but these two. So now we're gonna continue with hundreds, 400s. So the first smallest number that we could get will be 423. So what you notice is that I'm starting always at the smallest possible number that I can have in that particular range. So after 4, 2, and 3, I'm going to jump into 4, 2, and 5. So what you need to do is to just play with it. So 4, 2, 5. So I cannot have any numbers from 423 to 420 plus. So now I'm going to go to the next possible number. So 425. So that means we have to look for 430 plus. So if I choose 4 and 3, my other options will be 432, which is the next one. And the other one will be 4, 3, and 5. Okay, now if you're going to think about it, there will be no other options aside from these numbers because the highest one would be 450. So we could not get any number possible for that. Okay, so that means those are the numbers that we require, the question require us to answer. All right, number 6, it says match each calculation in a box to the correct answer. So, how are we going to get the answer for this question? So just like what we remember every time we see the word off, that means we have to multiply. So it says here 1/2 of 56, so that means 1/2 times 56. 56 will give us 28. Which means that for us to get 1/3 of 78, then we have to multiply 78 to 1/3. Or we can say 78 divided by 3. So 78 divided by 3 is 26. So we're going to put the line to the 26. And then the next one is 1/4 of 92. So that means 1/4 times 92. Or we can just simply divide 92 by 4. So 92 divided by 4 gives us 23. Put a line on it. And then the next one is 1/5 of 125, which means 1/5 times 125 divided by 5, which gives us 25. And that's how we got the answers there. Okay? All right. Now let's move on to the next page. The next page is asking us to put a tick on each row to complete the table. So it says here greater than 1/2 and less than 1/2. So just like what we discussed before, how would we know if a number is greater than half or less than 1/2? So if we are going to compare it with this fraction, so the fastest way is to look at the half of your denominator. So the half of 4 is, or the half of 4 is 2, which means that after looking at the half of 4, we can see that it's 2 and the number on the numerator is 3, which tells us that this number is, or this fraction rather, is greater than 3/4. Alright, so now we're gonna answer 0.05. So 0.05 tells us that, 1/2 can be expressed in terms of decimal as 0.5. Now, if you're going to compare it, 0.5 and 0.05, we can also express 0.05 as 0.50. So just by simply looking at these digits, we can understand that this number is less than, or this decimal number is less than half. Okay, so again, for this fraction, we have a denominator of 100, which means that half of that is 50, and then after getting the half, we can compare the numerator to the half of the denominator. So as we can see, this 34 is smaller than the half of 100, which is 50. So that will tell us that this 34 over 100 is less than half as well. All right? Okay, now we're going to problem number 8. Problem number 8 tells us to put one of the digits 0, 1, 2, and 6 in each box to complete the calculation. Now, it tells us to pay attention to this one. It says you put only one. And it says here that each digit can only be used once. So that means you cannot repeat any of these digits inside those boxes. So one box is one digit. Now, what you can see here is that if you pay attention to the answer, it will somehow tells us that, okay, the last digit is a 0, so that means the number could be multiplied by a number with a 0 at the end. So just like saying 15 times 10 will give us 150. So as you can see, the digits here are just being repeated, and the answer with a 0 was possible because it was multiplied by a number of 10. Now, what could be the next possible number? Alright, so if you are going to look at it, alright, so we have a number that when we multiply, so our only options is 1, 2, and 6. So we have to think of a number that when we multiply using 1, 2, and 6, the number must be equivalent to 126. Alright, so if you are going to look at it, if you will multiply 21 by 6, it will show us that the 6 will be the same, and the 6 multiplied by 2 will give us 126. So that means the 21 was multiplied by 6. So that means the last 3 digits was multiplied by this particular 6. Alright? Okay. So for this, problem number 9, it says, find the perimeter of this regular pentagon. So coming from the word regular, that means all the sides are equal. Now, if all the sides are equal, then automatically that means that this is 8.5, 8.5, 8.5, 8.5. Now, when you say perimeter, that means we have to add up all the sides for us to get the perimeter. Now, the fastest way for you to get that, since this is repeated addition, then that means the fastest way for us to do repeated addition is what? It's multiplication. So that means we have to multiply 8.5 by 1, 2, 3, 4, 5 times. Alright? So if we multiply 8.5 by 5, that will give us an answer of 42.5 cm. Now, it's okay if you don't, if you're not used to multiplying. So what you need to do is to just add up 8.5 5 times. 2, 3, 4, and 5. And if you add them up, that will also lead you to the same answer. Okay? All right, let's move on to paper number 6, page 6 of the paper. Triangles A and B are drawn on a square grid. Okay. Triangle A is translated 4 squares to the right and 1 square down. So that means you have to translate this shape 4 squares to the right. To the right, that means going this way, and 1 square going down. So just like what we discussed before, the first thing that you need to do here is to look for a certain vertex or a certain corner of the picture, and that is the point that you are going to translate following the directions. So let's say, for example, I want to move this one. So moving this one requires me to move these vertex 4 squares to the right and 1 square down. So if I'm going to do it, this is what it's going to look like. All right. So 1, 2, 3, 4, and then 1. So let's say this is your vertex number 1. So your vertex number 1 will automatically go here. Now from here, as you can see, this vertex is connected to another vertex 2 squares up. So that means the next vertex will be 1, 2 squares up, and you can simply connect them. Now from the vertex 1, let's say this is vertex 2 and this is vertex 3, what you can notice is that this square vertex 1 is 3 squares away from the vertex 3, which tells us that this one will also translate to 3 squares after vertex number 1. So that means the vertex number 3 will go to that spot. And only connect these dots for you to get the answer. So this is now the triangle in the new position. All right. Now it says here, describe the translation which moves triangle A from its original position to triangle B. So what the question requires us to do is to see the movement from A going to B, or tells us that how this A went to the position of B. So the same procedure is what we're going to apply. So just like this, we're going to count how this vertex 1 reached this spot. So let's try to count. So if I'm going to count it, this is going to be 1, 2. So that means 2 squares going to the right. So I'm going to write it 2 squares to the right. And then, after having 2 squares to the right, these will go down. So 1, 2, 3. So 3 squares down. Which means that the other vertices will follow the same direction. Now, if you are not sure about that particular answer, then you can just try moving these vertices following the directions that we had. So let's say it's 2 squares to the right, 1, 2, and 3 squares down, 1, 2, 3. So this is where the spot is going now. Okay. All right. Can you get it? All right. Now this time we're going to go to problem number 11, which says orange are sold in bags of 6. Okay. A school needs 260 oranges. So how many bags will they need? Okay. So in here, what we need to understand is that each bag contains 6 oranges. So if I'm going to write it down, this will tell me that this one has 6 oranges inside the bag. Now, you need to have 260 oranges, which tells us that for us to get that, we need more bags to reach 260. So what we need to do here is to divide 260 by the number of oranges in one bag for us to know how many bags do we need. So the next thing that we need to do here is to divide. Divide, this will be 4, 24, and 2, 23, 18, and 2. Now, what you're going to notice is that the answer will become 43 2 over 6, or we can express it as 43 and 1/3. Now, why do we say that the answer is 44? Now, it says here that you can only buy the oranges per bag, which means that it's impossible for you to just get 1/3 of the amount for every bag. So that automatically means that we have to buy one full bag for us to reach 260. So that means we rounded this number up for us to get the whole 260. So the answer will become 44. All right. Let's go to the next number. It says Imran starts with 1 and counts on in 5s to give this number patterns. Okay, so let's try to read it again. The pattern continues in the same way, so it adds up by 5 every single time. So 1 plus 5 is 6, 6 plus 5 is 11, 11 plus 5 is 16, and so on and so forth. The question is, will he ever find a number in the 5 times table? So, the question is asking us, will it be possible for us to get an answer in a 5 times table, which means a multiple of 5 or multiples of 5? So, what are the multiples of 5? Like 5, 10, 15, 20, or any number that ends up with 5 and 0. So, think about it. Would it be possible for Imran to get a number that ends with 5 and 0? Okay, so the answer here is a no. Why not? Alright, so as you notice here, the digits on the unit spot or the ones place always end up with either 1 and 5. So we can just say that the digits or the ones place or the units place end up with either 1 or 6, which is impossible, which are not, or we can say which are not multiples of 5. Alright, so knowing that the multiples of 5 ends up with 5 and 0, and these numbers end up with 1 or 6, so we can say that it's impossible for us to get a multiple of 5. Okay, let's go to problem number 13. It says Aisha is counting on in steps of 0.3. So when we say in steps of 0.3, it's just like step counting. Everything jumps up to 0.3. So 0.3 plus 0.3 plus 0.3. So if this is 0.8 plus 0.3, that will give us an answer of 1.1. 1.1 plus 1.3 is 1.4. We got it there. So 1.4 plus 0.3 gives us 1.7. And that's how we answer this particular problem. Okay? All right. Now, it says here, match each shape, to the percentage that is shaded. So one is done for you. So we get this as 60%. So how did we know that this is 60%? So based on what we studied before about percentage, the first thing that we need to do is to look for the fraction form. So this one is 1 over 4. This one is 3 over 5. This one is 3 over 10. And this one is 1 over 5. Okay. Now, if this is the thing, the next thing that we need for us to change this into fraction form is what? All right, that's good. Multiply everything by 100% for us to know the values. Or if you can mentally, solve it, then that would be great. So 1/4 of 25 tells us that this is 25%. So we move it to 25%. 3 over 10 times 100% gives us 30. And 1/5 times 100% is 20%. Okay. All right. So I'm just gonna stop here from this video, and I will continue this later on. That will be it for now. I'm gonna continue the next one later on. Goodbye and have a nice day. Okay. Good morning, kids. This is Mr. Ronald again. And this time we're going to continue with problem number 15. Alright, so I intentionally cut the videos every single time just to manage the time lapse of the video. Alright, so problem number 15 tells us that the graph shows Hakim's cycle journey between 1 p.m. and 5 p.m. How far does he travel between 1 o'clock and 3 p.m.? So as you can see here, he started at the 0 kilometer, which means that he left his home going and reaching this particular direction or this particular distance when he reached 3 p.m. So from 0, he went going to kilometer number 15. So that means he reached 15 kilometers traveling from 1 p.m. until 3 p.m. Okay, now let's try to look on how to answer letter B. What might he be doing between 3 p.m. to 4 p.m.? So as you can see here, the line graph is flat from 15. So from 3 p.m. going to 4 p.m., it was just there. Okay? The kilometer or the distance did not go up and did not go down, which means that the distance is still fixed. So what could he possibly be doing at the time? So there are many other possible explanation that tells that he stopped. He stopped because the distance did not reach any further. So we can just say he stopped, probably by taking pictures, or it could be he had a rest, or he could be, he saw a restaurant and ate there, or, like taking pictures or whatever. Okay. So the important thing here that we need to focus is this phrase that he stopped, or he did not move at all. Okay. Or let's say he got his tire. He stopped because one of his tires got flat and he need to mend it. Okay. Now, let's go to problem number 16. It says here are 4 calculations. All right. So use greater than, less than, greater than, or equal to make each number sentence true. So since this is paper 2, you can use your calculator to easily calculate these numbers. So if you're going to calculate 57.25 times 12.5, that would give us 715.625. So if this is 715.625, then what could be the symbol here be? Is it greater than or less than? Or equal? So 715 is less than 750. So that means this would be the symbol. So how would we, like for some of us who are still confused on how would we know that this symbol is greater than or this symbol is less than? So the best way for you to do it is to think that this is like a mouth that eats a huge number. So the mouth tells us where to eat the bigger number. Okay?
Never mind.
Okay. So now that's my son there. All right. So now we're going to go to the next number, which says 1000.5. So we're going to write 1000.5. Oops. 1000.5 minus 249.8. So when we calculate that, the answer is 750.7. This is 750.7. And then upon getting the answer, we compare. So 750.7 is bigger than. So just like what we say, the bigger number is the one that we are going to chunk. Alright.
But why, Papa?
Alright. Now we got 452. Point
Why, Papa?
75 plus 297.25 is equivalent to 750. So 750 is, well, equal to 750, and that's how we got the answer equal sign. Okay? Now, if we divide 600 by 0.8, so 600 divided by 0.8 will give us an answer of 750. Is it 750? You sure? Okay, so that's 750. Okay, so that means they are equal. All right. Moving on to the next page. It says here, draw a ring around each prime number. So, draw a ring. It says not tick it or not cross it. So, Cambridge is very particular with that. So, following instructions is one of the things that Cambridge is really particular with. All right, so prime number. So, just to give us a review on what the prime number is, a prime number is a number that only got 2 factors. That number itself and 1. So there are no other possible factors. Let's say, for example, 3 is a prime number because the only factors of 3 is 3 and 1. So now what you're going to do is to choose a number that only got 2 factors, which is that number and the 1. So that one will be 7. The next one would be 11. Yes. Alright, any other possible number? Okay, the answer is 17.
Papa, I want to take a rest first.
Yes, you may take a rest. Okay, you need to be quiet because I'm talking to my students, okay? Alright, now here are 6-digit cards. Rounding to number 18. Use 4 of the cards to complete this number sentence. Alright, so what you need to do here is to choose numbers to show that this fraction will be equal to this fraction. So let's say, for example, I use 1/2. Okay, 1/2. So now I'm going to think of a number that I can put to this number so that this will be equivalent to half. Alright, can you think of a number that is equivalent to half? Okay, so that would be 3/6. Now, there are many possible answers that you can get here. Let's say, for example, we got 1/3 is equal to 2/6. We can also say that 2/3 is equal to 4/6. Or we can say 2/4 is also equal to 3/6, which is 1/2. Alright? Or you can also express this as 2/1 is equal to 6/3, which is the opposite of this. Okay? Or 3/2 is the same as 6/4. Same thing. Or we can say that 4/2 is the same with 6/3. Okay. Now let's go to the next number, number 19. It says that an apple costs $1.60 for 500 grams. So if you are going to buy 500 grams, then that means you have to pay $1.60. Now, the question is, what is the cost of 2 kilograms of apples? Alright, so let's say that we want to know how many 500 grams can we get from 2 kilos or 2 kg. So we know that 1 kg is equivalent to 1,000 grams. So how many 500 grams can we get from 1,000 grams? So that means you're going to get 2 sets of 500 grams. Now, if that's 2 kg, then that will automatically give us 4 sets of 500 grams. Now, if that is the case, then that means you are going to buy 4 sets of 500 grams, which means that for you to know how much you're going to pay, then that means you have to multiply 1.60 or 1.6 by 4. So the answer there will be, okay, 4 to 6 point, okay, so the answer there will be $6.40. Okay, so you don't need to write the unit because the unit is already there. Okay, move along. Here is a diagram of a cube. The question is, how many edges does the cube have? So when we say edges, what does it mean? When we talk about edges, that means we are going to see how many lines can we get from this cube. Now, so I'm going to give you a technique on how to get it. Alright, so imagine that this cube has these imaginary lines at the back. What you need to do is to count from the bottom going to the top. So let's say, for example, I have this as 1, 2, 3, and 4. So there are 4 lines at the bottom of the number. The next is going to be the middle lines. So there will be 1, 2, 3, and 4. So there are 4 numbers on the middle line, or 4 lines on the middle part. And then the last one will be 1, 2, 3, and 4. So from there, we understand that there are 12 edges for the cube. Alright, next question says, how many vertices does the cube have? So when we say the vertices, then that means we are pertaining to the corners. Okay, the corners. So the same procedure is what you need to apply. So the corners are like this. So from there, what you need to do is to start from the bottom. Okay, start from the bottom here, 2, 3, and 4. Now, as you can see, it's just the same to what you can see on top. So there are 4 also on top, which tells us that there are 8 vertices or 8 corners in a cube. All right. Now, let's go to problem number 21. All right. Now, I need you to pay attention to this one because some of you might be could have been confused on how to answer this. So let's discuss. Here's a bus timetable. How long does the bus take to get from Belleville to Doham? So this is the Belleville, and the bus will go directly to Doham. All right. So what you're gonna notice is that from Belleville, the time, let's say if you leave at 8:05, that means you're gonna reach Doham at exactly 9:13. So what we need to do is to subtract the time for the Doham by the time of Belleville. So this is going to be 09:13 minus 08:05. Okay? So as you can see, this one will give us 08. Okay, and this one will give us 1. So the distance or the time to travel from Belleville to Doham is 1 hour and 8 minutes. However, the answer requires us to give it in the minutes form. So that means this 1 hour has to be converted into 60 minutes, added by 8 minutes. So that means the answer here will be 68 minutes. All right. Now, it says here Tula gets on a bus at 14:45 and gets off 53 minutes later. Where does she get off the bus? Okay. So where does she get off the bus? So the first thing that we need to understand here is she took the bus at 14:45, which means she went to this particular station wherein the time of the bus to leave is 14:45. So what you need to do is to look around this table on where you can see this time 14:45. Okay? So which town would it be? Alright, so this is 14:45. So that means she left a town. And then she traveled 53 minutes later. So from 14:45, we are going to add up 53 minutes. So this will give us 14:98. Okay. However, we still need to change this 98 because it exceeded 60 minutes. So this 1 hour, which is 60 minutes, would give us an hour. So this will be 15:38. Okay. Now, what you need to do next is to see on which town shows us this time 15:38. Okay, where could that be? Alright, it's here. So that means, where does she get off the bus? She got off the bus at the city. Okay. Now let's go. We still have 1, 2, 3 pages left for us to answer.
Papa, Suka, I want to get the shoe.
All right. Okay. Do it first. Bu. Afaro. Afaro. Okay. All right. So plot the points 5. It says here plot the points 5, comma negative 3, 3, comma 3, and negative 3, comma 3 on the grid. Okay. So letter A is already here. And then we have to plot 5, comma 3. So the first thing that we need to understand is the movements of the x and the y numbers. So xy, xy. So if we are going to plot letter B, so that means we're going to move it at 5, negative 3. So 5, negative 3 will be here. 1, 2, 3, 4, 5. And negative 3, 1, 2, 3. So that means that your B is here.
I want to reread.
All right, next would be C is 3, comma 3. Okay, so from here is 1, 2, 3, 1, 2, 3. So that means this is your B, this is your C. And then your D is at negative 3, comma 3. So from 0, 1, 2, negative 3, and then 1, 2, 3. Okay, so this is your letter D. Okay, so upon plotting the points that we got, what we need to do next is to figure out the shape. Okay, so figuring out the shape, we have to connect all these dots by following the alphabet. So A to B, B to C, and C to D. Okay, so what shape did we get? All right, it's a trapezium.
What? Papa, I got the question.
Okay.
What's a trapezium?
Okay, now we're going to complete these calculations on problem number 23. So it says 5 plus 2 times 3. So what we need to think about here first is the PEMDAS rule. So that means if we see a multiplication or a division in a particular problem, that's what we need to solve first. So from here, we solve the 2 times 3, which is 6, added by 5, which gives us 11. Okay? And then here, what we need to do is to solve all the multiplications first. So this is 30 plus 8, which gives us 38. Okay? All right, now let's move to the next question. Okay, fill in the missing numbers to make this subtraction correct. All right. So what we need to do here first is to understand that we have to supply a number that would fit in to this particular thing. So subtraction is this number will be subtracted by this number, and this is what we're going to get. So that means if this is the subtraction, for us to get the number previously, what we need to do is to add them up. So if this is 2, so that means something was subtracted here for us to get a value of 2. So automatically we're going to think that this is 10 because something was taken off from there. So here, this is 10. 10 minus blank is equal to 2, which leads us to 8. All right. Now from there, what you need to do here next is to think. If this number was taken by 1, this will be 6. So we're going to be 6 minus 4 will lead us to 2. All right. Now, in here, it tells us that this number was subtracted by this number and it reached 9. So we're going to think, okay, this number borrowed 1 from here, so this becomes 13. So the 13 was subtracted by this number, and the answer is 9. So we can say that this is 4. Okay. So now, since this is 4, what we need to understand here is to get this number next. Now, do not forget that we took away 1 from this particular number. So how can we possibly get this particular number here? So there's a technique. So from here, you're going to do it backwards for us to get the original number. So you're going to add this value, 6, added by 8 is 14. Plus the number that you took away previously, which is 1, which gives us an answer of 15. So that means this number has a digit of 5. So if you're going to think about it, I took 1 from here, it became 4, okay? And then this number became 14, and I subtracted it by 8, the answer becomes 6. All right. Now, for this one, as we know, this was previously 4, and that means this 4 borrowed 1 from the 3. So the 3 became 2, which made it a value of 14. So that means if I subtract this to nothing, the answer here will be 2. And that's how we got all the blanks in the answer. Okay? It's a bit complicated, but if you are going to think about, logically and how this thing, it will be easier.
I don't hear the song.
Alright, let's go to number 25. Fatima has some pants. She gives 3/10 of her pants to her brother. Okay? She gives her brother 12 pence. How many pence is she left with? Alright, now for us to answer this one, what we need to understand that this 3 units is equivalent to 12 pence. And the 10 units tells us the total number of pence that Fatima has. Now, in this case, what we need to understand is we are going to look for the leftover. So, 3 units is the one that was given to the brother. The total is 10. Then that means 10 units minus 3 units will give us 7 units, which tells us that the 7 units is the leftover items. So what we need to do here is to look for the value of 1 unit, which gives us 4 pence, and then try to look for the value of 7 units, which is 4 times 7, which is 28. Okay, so the answer here is 28 pence. Alright, let's go now to problem number 26. Problem number 26 shows us the test scores for each group, for a group of 100 students. Now, we have to pay attention to that. It says 100 students. So that means if we add the number of students, all of them will reach 100. Okay. Now, it's asking which score is the mode. So when we say the mode, then that means the most appearing score in the choices. So the scores are 0 from 0 to 10. So if we are going to think about it, we are going to look at the score wherein most of student got that particular. Okay? So as you can see, let's say for example 0 is 0 students, so that means no one got a score of 0. So 1, so that means 4 students got a score of 1. 2 is none. Okay, so what you need to understand here is you have to look at the most appearing or most total number of students that acquired that particular score. And as you can see, this is the answer. The number of students that has the most is 20, which means that you have to pay attention to the score and not to this particular number. So the score here will be 6. All right, not the 20, but the 6, because we are focusing with the score. Okay, letter B. What percentage of the students scored less than 3 marks? So when we say less than 3 marks, does that mean that 3 is included? No. Okay, so when you say less than 3, that means 3 isn't included. So that means we need to pay attention to the numbers below 3, which is 2, 1, and 0. So as you can see here, from 2 to 0, only 4 students got a score. All right, so 4 out of how many? Okay, now let's go back to the question here. It says here 100 students. So we can say that this is 4 out of 100 students. So if we are going to change this into percent, then that will tell us that the answer here is 4%. Okay, so that's it for me now. I hope everyone understood the explanation. If you have questions, you can reach me at the Google Classroom, or you can send me an email with regards to particular questions that you're having problems with. Okay, that's it. Goodbye, class, and have a nice day.